slopes of parallel and perpendicular lines, the hardest part is getting them mixed up. After you know what they are, it's pretty simple. So we have parallel lines. Parallel lines have the same slope. And this actually makes sense for them to have the same slope because parallel lines never intersect. So if parallel lines have the same slope, then that means that the lines never intersect. Because if they're increasing at the same rate, they will never intersect. When lines never intersect, this means the rate of change must be the same. Parallel lines can have different y-intercepts. So again, if a line is parallel to another line, that means that these two lines will always have the same distance in between. They will never intersect. So if they have the same slope or the same rate of change, then that means that it's impossible for them to ever intersect. So an example, we could say we have the equation y equals 3x plus 1. Well, a line that's parallel will have the same slope, and the slope is 3. So we could say 3x, any y-intercept, because the y-intercepts can be different. So let's say minus 4. These lines are parallel because these slopes are the same. Now for perpendicular lines, it's a little bit different. So perpendicular lines have opposite reciprocal slopes. And we'll go over what that means in a minute, because lines that are perpendicular have to intersect at 90 degrees, which means they have the exact opposite rate of change. So when I said reciprocal, reciprocal is like the opposite. Okay? So if we had a slope, for example, of y equals, we'll say 2x plus 4, where 2 is the slope, the opposite would be a negative. The reciprocal would be if we turn this into the fraction. So the opposite reciprocal would be y equals negative 1/2 x, and then we can change the y-intercepts. That's this last part. So perpendicular lines can have different y-intercepts. So again, we have this slope and we have this slope. This too has an imaginary 1 underneath it, and so because it has that imaginary 1 underneath it, when we take the whole number and we flip it, it becomes 1/2. And then we have a negative because this slope was positive, and those lines have to intersect at the exact opposite rate of change. So this is what that would look like. They intersect at the exact opposite. So this one's increasing, increasing, increasing at a rate of change. This one's decreasing, decreasing, decreasing at a rate of change. That's why it goes from a positive to a negative. For any whole number slope like this, when you do the opposite reciprocal, 1 will always be in the numerator.